Here is another example in our review of factoring. Here we have 2x squared plus 5x plus 3. This problem is sometimes a little more challenging because the greatest common factor here is a 1, since the only number that will divide into a 2, a 5, and a 3 is a 1, and since we cannot pull an x out, since there is no x term here. But also, the leading coefficient, which is the coefficient in the very front, is not a 1. Sometimes this poses students a little more challenge. We can still factor it into a product of two binomials. We'll just have to think about how to do it. Let's see. What can we put here and here so that when we multiply, we end up with 2x squared? There's really only one way to do that. It must be a 2x and an x, because 2x times x does give us 2x squared. As usual, we look at this term to decide, are these signs going to be the same or different? These signs have to be the same since this is a positive. Which the same? Are they going to both be pluses or are they both going to be minuses? I can tell from this that they're both going to be pluses. So I will put a plus sign and a plus sign. Now, how can we end up with a 3 in the constant term? Well, these two numbers have to multiply together to give us this 3. It must either be a 3 and a 1, or a 1 and a 3. Let's check. If we put the 3 there, then the 1 would have to go there, and we would have 2x times 3 would give us 6x, and 1 times x would give us 1x. 6x plus 1x would give us 7x. That isn't what we want. We want a 5x. Let's try it the other way. Let's put the 3 there and the 1 there. If the 1 is there, we would have 2x times 1 would give us 2x. 3 times x would give us 3x. 2x plus 3x is 5x, so that is the way that it should be. We put the 3 there, and we put the 1 there. Again, let's check. 2x times 1 is 2x. 3 times x is 3x. 2x plus 3x is 5x, and so this has been factored correctly.